Now, at this point, you may be feeling overwhelmed by all of these strange ideas and be about to give up in despair. How can anyone ever understand such a bizarre theory? And if you can't understand it, how can you even think about using it? Here is the good news. Whether we think we understand quantum mechanics, and whether there is yet more to discover about how it works, quantum mechanics is actually surprisingly straightforward to use. The rules and the approaches for using quantum mechanics in a broad range of practical problems and engineering designs are relatively straightforward. They use the same mathematical techniques that most engineering and science students will already have mastered to deal with the classical world. And because of a particular elegance in the mathematics of quantum mechanics, namely that it is based entirely on linear algebra, quantum mechanical calculations can actually be easier than those in many other fields. The main difficulty that the beginning student has with quantum mechanics lies in knowing which of our classical notions of the world have to be discarded, and what new notions we have to use to replace them. Indeed, it is this aspect that makes it very difficult to teach yourself quantum mechanics. Because such basic conceptual shifts are required, you simply can't pick up quantum mechanics just from encountering bits and pieces of it as techniques here and there. You really need to take a course that forces you through a fairly complete development of the subject's concepts. As you do this, you should expect to spend some time in disbelief and conflict with what is being inserted to you in quantum mechanics. That is entirely normal. In fact, a good fight with those propositions is probably psychologically necessary if you're ever to get on top of the subject. Incidentally, I should say that the associated teaching technique of breaking down the student's beliefs and replacing them with the professor's correct answers has a lot in common with brainwashing. And as we mentioned above, there is a key point that simplifies all the absurdities and apparent contradictions. Provided we only ask questions about quantities that can be measured, there are no remaining physical problems that need worry us, philosophical problems. At least none that would prevent us from calculating anything we could measure. As we use quantum mechanical principles in tangible everyday applications, such as electronic or optical devices and systems, the apparently bizarre aspects of quantum mechanics simply become commonplace and routine. You may soon stop worrying about quantum mechanical tunneling and Heisenberg's uncertainty principle. Perhaps in the foreseeable future, such a routine comprehension and acceptance might also extend to concepts such as non-locality and entanglement, as we start using those more in practical situations, for example, in sending secure information. For any of us, understanding quantum mechanics marks a qualitative change in our view of how the world actually works. That understanding gives us the opportunity to apply this knowledge in ways that others cannot begin to comprehend. Whether your goal is basic understanding or practical exploitation, learning quantum mechanics is, in my opinion at least, certainly one of the most fascinating things you can do with your brain.